Unit 1, Lesson 8, so Lesson 1.8, Intermediate Value Theorem. Intermediate means in between. So for example, if we have an interval from 3 to 8, any number between 3 and 8 is an intermediate value, like 7. 7 is an intermediate value. Or we can say 4.1 is also an intermediate value because it's in between 3 and 8. Understanding the intermediate value theorem. Here's a graph of f of x equals 0.5 x cubed plus 1. We know that the graph passes through the points 0, 1 and 2, 2, 5. So when x is 0, y is 1. When x is 2, y is 5. We also know that this graph is continuous. To go from 0, 1 to 2, 5, not surprisingly, we have to pass through every point. We can't jump anywhere because this is continuous. This function is continuous. Okay. So in math, we can say that if b is between 1 and 5, there's always a number a such that f of a is equal to b. Not only that, but we know that a is between 0 and 2. So there's somewhere in this interval. Because this graph goes from 0, 1 to 2, 5, somewhere on this interval, 0, 2, it must pass through every point from 1 to 5. So the intermediate value theorem says that if f of x is a continuous function, and if f of a equals m, f of b equals q, then for any number p between m and q, there must be some x between a and b such that f of x equals p. That sounds like a lot, but really, here's all. This is just what it says. To go from y equals a to y equals b, any continuous function must pass through every point between a and b. That's it. That's all it says. We have this function. To go from 0, 1 to 2, 5, we've got to pass through every point in the y-axis between 1 and 5. We can't jump because it's continuous. Why is this useful? Here's an example. A function has a root, say at x equals 3, if f of 3 equals 0. Another name for root is 0. For example, if we know that f of 2 is positive, like in this function, f of 2 is positive, and f of 4 is negative, since f of x is continuous, we know that since 0 is between a positive and a negative number, f of x must equal to 0 at some x in this interval, 2 to 4. So that means that f of x has a root between 2 and 4. Example. So how might the AP test ask you questions on the intermediate value theorem? Here are some examples. G of x is a continuous function with g of 1 equals 4, g of 4 equals negative 3, and g of 6 equals negative 1. Okay. Prove that g of x has a 0. Remember, 0 just means root. In the interval 1, 4. Sure. We know that g of 1 equals 4, g of 4 equals negative 3, and 0 is a number between negative 3 and 4. So by the intermediate value theorem, since g of x passes through every value between negative 3 and 4 in the interval, g of x must equal 0 for some x in the interval 1, 4. The key is just 0 is between negative 3 and 4, so we can use the intermediate value theorem. Example 2. A of x is a continuous function. A of 5 equals 8, and a of 10 equals 24. Explain why a of x equals 15 for some x in the interval 5, 10. Well, we know that 15 is between 8 and 24. So by the intermediate value theorem, there must be some x in the interval 5 and 10, because a of 5 is 8 and a of 10 is 24. That's where the 5 and 10 comes from. Such that f of, not f, a of x is equal to 15. That's it.